So let's start with the first topic, that is energy and human. Okay, so what is energy? Energy is the ability or capacity to do work, and it may be available in potential energy form or kinetic energy form. And so chemical energy is one example of potential energy, and energy is stored in that, right? And using that, you get the energy. Now, there were different. Now, we want to focus upon the alternative sources of energy. That is, in a way, you can say non-fossil fuel or even non-hydro type of sources. So, solar, wind, etc. So, in like ancient times, also you get some example of the use of solar energy. So, different images are given here, which depict that solar energy were being used in different ways, even in those cultures. And then the wind energy was also used in different ways. But of course, it was not at a very mass scale, right? It was in a way like small examples you'll find here and there. But the consumption of energy itself was not this high. Now the fossil fuel era started. That is the discovery of coal, and then the industrial revolution, and then the oil and natural gas discovery, and then the electrical power plants were built. Okay, so this led to very rapid rise in energy usage in the world. Of course, this graph is showing the human population growth. So what are the reasons why the energy usage increased? So one of the reasons is that the population of the earth has increased very rapidly, maybe in last 50-60 years. As you can see, like in 1804 it was just 1 billion. It increased to 2 billion in 1927, and then in 1960 it was 3 billion, and from 1960 to 2024, right? We are at 2020. So, and if you think of 2048, it will become three times. It will triple in this period of around 90 years. So right now we are around 8 billion. So like there has been a very rapid rise in the growth of the human population. And again, human beings also started using more and more energy. More products were available, so consumption increased, and then for producing those products, energy is required. So you are you and like in running many products, for example, like running your automobile, you need energy. And now like more and more people are using the like IC engine based vehicles. So the energy usage also started growing very rapidly, right? Now, what is the importance of energy? Like, why are you studying this subject, or why are we so much concerned about energy? So, if you think like energy is all pervasive, that is like activities, most of the activities yeah, I don't know so how this happened. Okay, so I've shared it again. So energy and GDP. So like energy is required for all different human activities and human endeavors, be it agriculture or be it industry or transportation, etc. So like like to perform different activities or economical activities or even day-to-day activities, or even service industries, they all need energy. Now, so in a way, you can say that energy is related with GDP, that is gross domestic product. You must be reading this word again and again, gross domestic product. So that's the value of the total product and services that are produced, and normally it is given per year. So you must be like hearing these words that GDP of India is going to grow at 7% or 8% now. Then because of this pandemic, it's going to slow down, and now it may grow just at 4% or things like that, right? So that is the gross domestic produce. So the value of the product and services are also included. So product and services, if you find its value, then it's nothing but the GDP. So that GDP is related with energy consumption, as you will see in one of the graphs. Now there is one table that is shown here. Now why is GDP important? GDP, in a way, GDP in a way it shows how economically developed a country is. But of course, if there is more population, then like GDP per person is perhaps more important. You can know the living standard of a country by knowing the GDP per person. So 5 different countries are given. Their total primary energy consumption is given in gigajoule per year. So all of you know the unit giga, 10⁹ joules per year. For different countries, it has been given in this table. Primary means the basic coming from the source, right? So it includes all different sources of energy, oil, coal, okay, you name the type of energy and it's included in this. So primary energy consumption for different countries, and you can see USA is the highest, China, I'm sorry, USA is second, China is the highest. But then the population of China is much higher than that of USA. So per capita energy consumption in USA is much higher, even as compared to China, and India is much below. It's just 25.5. So you can see that USA energy consumption is more than per person gigajoule per year. When you say per capita, it is per person. So it's almost 1/10 of this, right? Almost 1/10 of USA. But then the other developed countries like Japan and Germany are having somewhat less per capita energy consumption. So per capita energy consumption normally presents the standard of living, but then this doesn't mean that you should start wasting the energy. That doesn't mean that you should produce more energy and start wasting it, right? That is not affordable. Not affordable to in different ways. Not affordable earth as well as to environment also. Okay. Now, if you think about the like electrical power consumption, if you take the scenario of 2015, then this is like how many billion kilowatt hour, right? You know that the unit of electrical power, most of the time, one unit is kilowatt hour, 1 kilowatt hour. So if you this is in billion kilowatt hours. And again, electrical power consumption, this is 2015 data. So China is highest, followed by the United States, and then India, and then Russia. Okay. So electrical power consumption also is very high in China and USA. In India also, compared to many others, it is high, but then the population is also high. So per capita consumption becomes low. So generally, the living standard is like higher when the GDP per person is higher, but GDP will be higher if energy consumption will be higher. Okay, so that's showing a relation between GDP and energy. Then somebody may say that just GDP is not it cannot show the right picture how developed or how good is the living standard of a particular country is. So in that case, there is one index that is developed by UN, and that is called Human Development Index, HDI, Human Development Index. It's a composite statistic of life expectancy, education, and per capita income. Right. If one thinks that HDI is representing the living standard in a better way, then one may check how is the HDI of different countries in the world. This is again a graph for GDP, and as I was telling, normally this is per capita GDP, per person GDP in value in dollars, and this is per capita energy consumption. And as you can see, like the graph going like this, it means that if you want higher GDP, then the per capita energy consumption has to be higher. But then what you see is that it's not just a single line, right? There is some spread. It means it may be possible to consume less energy and still produce more GDP. But there is a relation between those two, right? Then, like I talked about HDI, that is Human Development Index, and Human Development Index of different countries are given, and here the Human Development Index is plotted against electrical power consumption per person per year, per person per year, electrical power consumption per person per year. So you can see that some of the countries which are very down below Human Development Index, right? Of course, India is also not very high in that. But then, you can see that some of the countries which are having a higher HDI are also consuming much higher electrical power per person per year. For example, Australia is one of the highest, and United States and Canada are also high. But then you also find that there is still some difference in the energy consumption or electrical power consumption, right? Like even with lower power consumption, Australia is having a very high Human Development Index. With somewhat higher energy consumption, Canada is maybe slightly below that, right? Like they are related, energy consumption and the development or living standard are related. But like if energy efficiency is better, then even with somewhat lower energy consumption, you can achieve higher development also. Okay. So this showed why we need to study or talk about energy, and why we should make the energy available or accessible, good quality energy accessible to all, in all different walks of life and all different walks of economy. Okay. So classification of energy sources. I talked about this somewhat earlier. Classification. So one of the classification could be renewable and non-renewable. So what is renewable? Something which can be renewed over a short period of time. That is renewable, right? So I was talking about hydro energy. So it's renewable in a way because like you have a certain cycle of rain, like water coming to the rivers and then getting stored in the reservoir, and you produce the power. Again, it goes back to the sea. Again, evaporation and cloud formation, and again rain. So that's in a way it's renewable. Bioenergy is also renewable. We also call solar, wind, etc. also renewable. They are not exactly renewed, but rather you can say they are eternal sources of energy. Right? The sources which are not going to get depleted during the existence of human. There won't be any period where you will say that now solar energy is exhausted or wind energy is exhausted, right? So life will vanish if that energy source is not available, right? So that way also you may call it eternal energy source or renewable energy source. Okay. Then other category could be, as I told, conventional, non-conventional. So conventional is what is mainstream, right? So that is mainstream. So like in medical, allopathy is conventional. It's a mainstream, but then you have different other alternative therapies or alternative medicines also, like Ayurveda or homeopathic, etc. So that way, uh, but then some of these energy sources may start becoming mainstream, like solar is growing, wind is also growing, but even now generally people put them as non-conventional energy sources. Hydro, though it is renewable, it is conventional, because for many it's there for many decades now. Right? Then one word was used: primary energy and secondary energy. So primary is what is available from nature, right? And then you might convert it into some other form. For example, electrical energy or hydrogen energy. So electrical energy is not directly coming from nature. What you have done is there is heat, there is like fuel available, chemical energy is available, converted to heat energy, and then converted to electrical energy. So that's secondary. So this is one way in which you can classify the sources of energy: conventional, non-conventional. In conventional, commercial and non-commercial. And then in commercial, you have coal, petroleum, electricity. Non-commercial, the firewood, straw, dried dung, etc. Non-conventional energy sources are also listed here. Now, what is the energy scenario in the world? Like how much energy, let's say in gigajoule also will be a small unit. So exajoule unit is used. So 10 raised to 18 joule is exajoule. So how much, so in, you can say it's 10 raised to 9 gigajoule. So how much energy is being used in the world, and it is coming from which source? So percentage wise, which source is the most important or most dominant? And then what might happen in future? And if we are dependent upon one particular source, for how much time period it is going to it is going to exist, and then whether it's a clean source or it's a polluting source. If it is a polluting source, then what is the impact on the environment and human health? Whether the use of that should be encouraged or discouraged. So all those things you can tell you only if you understand the energy scenario in the world. Now there is one unit which is also used many times, and that is called tons of oil equivalent, right? Because like oil is a very dominant source of energy. So tons of oil equivalent is how much? uh, so ton is 1000 kilograms, or 2204 pounds, or 7.4 barrels of oil. So how much energy will this oil give? This will give 41.87 gigajoule energy. So when you say 1 ton of oil equivalent, TOE, then you mean that the energy is equal to 41.87 gigajoule, or it's 11.63 megawatt hours, right? So many times some figures of the energy consumption are given in tons of oil equivalent, right? So yes, so how is the like somewhat similar graph was seen for population. Now this is for energy. How has the energy usage in the world grown? So before the industrial revolution, the fossil fuels were not at all common, and the energy consumption was quite low. But with industrial revolution and availability of different types of fuels because of mining and drilling, etc., as well as electrical power becoming very common, the usage of energy increased very rapidly. As you can see, somewhere after 1950, the usage has increased very rapidly, and that trend continues. Now, out of this total usage is in exajoules, right? So 10 is to 18 joules. Uh, how which source is contributing how much? So you can see that nuclear electricity, the first one, little bit contribution; hydro, a little bit contribution; Natural gas is quite important. Uh, Crude oil is also very, very important. Coal is important, and biofuels are also playing an important role. Now, like this is a very wide range of years, but if you start from 1993 up to this is up to 2018. So, which source is contributing how much? You can see oil is very important, mainly in transportation. Natural gas is also like its share is increasing. One of the reasons is that it's comparatively cleaner source of energy. Nuclear energy has a steady contribution and a steady contribution, right? And then hydroelectricity also has a steady contribution. Renewables are growing a bit, and coal is also having very important contribution. So this is about the percentage contribution by different. This is world scenario. Now, how is it important for us? So, if you compare the energy consumption, primary energy consumption, uh, primary energy consumption per person per capita, for like USA, it was like this is tons of oil equivalent. So it was this much. It was higher. This is 2000, and this is 2013. So per person, this doesn't mean that the energy consumption has decreased. Per person, it has decreased. One of the reason could be that if you increase energy efficiency, even with same GDP, you can have a lower energy consumption per person. Right? But it's not the case for developing countries like China. It's per person consumption has increased rapidly in these 13 years. World average also increased. India also has increased. So if you look at 1973 and 2015 scenario and compare them, what you find is that oil was very, very important up to 1973. But then this is percentage and this is total value. So first thing that you should read is this number. Okay. Now while looking at all these graphs and charts, you might be wondering how it can be asked in exam. So like you cannot be expected to remember all these numbers and write down those numbers in the form of question and answer during in the exam. But what might be done is like I can upload some of the previous papers. So what you might expect is that some diagram like this is given, and then you are asked to interpret that, right? Like comprehension kind of thing. Like you are shown this graph, and then you are asked certain questions, which can be you have to read this diagram, right? In engineering, it is very important to be able to interpret the data, and data are many times expressed in a graphical form. So this graphical data in a graphical form, you should be able to understand and digest this data. Like the 1973 and 2015 scenario is given. What was the total energy consumption of the world in 1973? It was 3740 metric tons of oil, million tons of oil equivalent, and it has kind of not exactly doubled, but maybe 60-70% rise, and it has become 5269. But still, it's a very significant rise because it has occurred only in 50 years. Uh, yeah. And this pie chart is showing the percentage contribution. So when oil percentage is lower, doesn't mean that oil usage has decreased, right? Percentage wise, it has decreased. So what you have to do is this percentage multiplied by this number, that will give you absolute consumption of oil. And similarly, this 52.6 multiplied by 3740 would give the absolute consumption of oil. And you can do it for any one of this. So the oil is still important, but like it's compared to others, it has its contribution has decreased. One of the reasons for this is like higher prices of oil, one and so you cannot afford it at least to generate power plants, right? Except maybe few countries in the Gulf. Okay. Then natural gas with more discovery and being a bit more cleaner source, its contribution has increased. And then nuclear contribution also has increased significantly. Percentage wise, hydro hasn't changed much, and biofuel and waste have also increased from 2.3 to 5.8, and others also, they were almost non-existent, right? Negligible, as you say, 0.2%, but now it is 2.1%. So these others include solar, wind, etc., renewable sources. Of course, the scenario is changing very rapidly, and renewables are getting more and more importance. This is electrical power generation. The previous one was primary energy consumption. So it shows all different sources used in all different ways, right? So this will also include the cooking gas, right? While now the chart that you have is only for electrical power consumption. So which fuel is contributing how much for electrical power production, not consumption, generation. So generation in 73 it was 6131 terawatt hour, and it has become almost 4 times. So you can see electrical power is has penetrated much into the like economy or industry. So its usage has become 4 times, almost 4 times in this period of around 50 years. Okay. Now, earlier oil was contributing significantly, but now oil has a very little contribution. It's too costly to use oil for this. Natural gas had 12.1, but it has increased significantly to 21.5. Nuclear also has increased significantly. Hydro has percentage-wise it has decreased, but still it is very important. And others are 6.3. So this others include solar, uh, biomass, like the electrical power produced from biomass, wind energy, etc. Okay. Now the global electrical power generation. Uh, so, like what this is the current scenario. This is like some of these columns will give you numbers very similar to this, but then this is giving it in terawatt hour, right? So tera is 10 raised to 12, right? And this is giving you in kilowatt, trillion kilowatt hours, right? So, so this is a basically column chart, and this is also giving you probable future scenario because it is mentioning 2025, 30, 35, 40, right? So as you can see, in future renewables will play more and more important role in electrical power generation. As you can you know that solar is getting more and more importance, and so is wind and biofuels. Okay. And then natural gas is also becoming important, more important. Nuclear is also slightly growing, and coal has also grown a bit. Right? So this is the like future scenario, probable future scenario for the world. So now you know that renewable energy source or alternative energy sources are also important uh, to develop. One needs to develop that also. So this was the world energy scenario. So previously I talked about like the first thing that we talked about was the importance of energy, how it is related with the growth, living standard, human development index, this GDP. So like you need energy for growth. Of course, energy efficiency is also as important. One should not waste energy, and it should not like you should have somewhat uh, uh, like uh, uh, it cannot be exactly equal, but there should be some parity between the usage of energy in all different sections of the society. So it's not that most of it is consumed only in urban areas by only a few percentage of people. It should be available to large sections of society, even in rural areas or somewhat lower economical class also. So accessibility to energy and good quality energy is important. Then that will lead to economic development and overall development of human being. So energy is important. Next thing is that, like, the world energy scenario, the primary energy scenario, and the electrical power scenario was presented. So from that you understand what is the relative importance of different fuels. As you could see that oil is though still very important for transportation. For electrical power generation, it is not as important. Natural gas is becoming important. Coal growth also, like, you cannot stop using it, but then renewables are also becoming more and more important, right? So that's the lesson that you learn from this session. Now the next topic is the energy scenario in India, and I think we'll take it in the next class, right? So I have given you the timing for the next class, and we'll follow it accordingly, right? And I will put this recording in either in this Microsoft team, in this team, or I may upload it on my channel on YouTube, and I'll provide you the link for the channel, right? So I'm stopping the recording here.